G'day everyone. Today we're going to be learning about limiting sums. In this lesson, we'll take a look at the equation to solve a limiting sum, the proof into how we get that equation, as well as taking a look through a few examples. So let's get into it. The block of text here explains what the equation is for a limiting sum and how we get there. But what actually is a limiting sum? Well, it's essentially a subset of a geometric sum or a sum of a geometric series. So a geometric series is a series where we have a common ratio, so something like 2, 4, 8, 16, and so on. The common ratio in this example is 2. But if we had something like 1, half, a quarter, 1/8, and so on, the common ratio here is 1/2. So we are dividing by 2 for every next term in the sequence. So in this case, we have r is less than 1, and in this case, we have r is greater than 1. So to sum these series, what we do is we use the formula where the sum of the series up to the nth term is equal to a outside of r to the n minus 1 over r minus 1. Alternatively, when r is less than 1, our common ratio is less than 1, as is in this example here, we have a outside of 1 minus r to the n on 1 minus r. These two equations are equivalent. They will get you the same result. However, it's just easier to use each result when r is either greater than 1 or less than 1. So that brings us now to limiting sums. So a limiting sum is just when this common ratio, as I said before, is greater than 1, is less than 1 and greater than -1. And essentially, it is the sum of a series that goes on infinitely. So for these equations up here, right? For these equations up here, these are for n terms. But if I wanted S infinity, which is the sum of infinite terms in the series, if I have something like a series that's equal to 2, 4, 8, 16, we can see that each term is getting larger and larger and larger. So if we were to sum all of these terms infinitely, well, the value that we get is infinity. Eventually, we would reach some sort of upper limit, which let's call infinity. So there's no specific number that when we add all of this up, it converges to, or it approaches. However, in the case of 1, half, a quarter, 1/8, we can see that each term gets smaller and smaller and smaller. So when we try and add our terms, we have 1 plus half is 1.5, plus a quarter is 1 3/4, plus 1/8 is 1 7/8, and then the next term would be a 1 16, and 1 32, and a 1 64. So every term after the previous gets smaller and smaller and smaller, so we converge to some sort of point. And what is that going to be? Well, if we recall, we have the sum of n terms is equal to a outside of, now I'm going to use this formula here because when we have a limiting sum, our ratio is less than 1. So it's going to be 1 minus r to the n over 1 minus r. Now when n approaches infinity, r to the n approaches 0. And the reason for this is because r is less than 1 and greater than -1. So its value is some form of, let's say, fraction that's smaller than 1. So when we raise it to the power of something, it approaches 0. And so let's say r was equal to 1/2. R squared is equal to 1/4. R cubed is equal to 1/8. R to the 4 is equal to 1 over 16. And we can see we get smaller and smaller and smaller. So as the higher the n becomes, the smaller the number becomes. And so what we can see is that, well, when n approaches infinity, some sort of really, really large number, this ratio gets so small that it's eventually just becomes 0. So that means we say S infinity, the sum of infinite terms of a limiting sum, is equal to 1 minus 0, because r to the n we said was 0, over 1 minus r. And this just equals a on 1 minus r. So this is our formula for limiting sums. So hopefully that proof makes sense. And we're going to be using this formula to answer some questions. So this first example here says, explain why these series have limiting sums and find them. So for part A, we see that we have the series 18, 6, 2, and so on. The common ratio is going to be 6 over 18, which is just equal to 1/3. And so why is it a limiting sum? Well, it's a limiting sum because our ratio falls in between -1 and +1. So it's a limiting sum. And if we recall, the sum of a limiting sum is a, our first term, over 1 minus r. So in this case, it's 18 over 1 minus 1 over 3. If we put this in a calculator, what we get is 27. So we converge to this value of 27. Part B is going to follow the exact same way. I'll do it on the other side. So part B will follow the exact same way. And what we see is a very, very similar formula to what we had in part A. So we have 18, 6, 2. But a key difference is that we have this alternating plus and minus. And what this is these are just different terms of a sequence that we are adding together. So it's 18 plus -6 plus 2 plus minus whatever the next term is going to be. And then let's call it x and so on. So to find the limiting sum, let's first find the common ratio. So our r is equal to -6 on 18, which is equal to -1 over 3. And this, yet again, satisfies the condition that our common ratio is between -1 and +1. So therefore, we have a limiting sum. And S infinity, our limiting sum itself, is equal to our first term, a on 1 minus r. Plugging in these values, we get a on 1 minus -1 over 3. And now if we plug this into a calculator, what we get is, what do we get? 27 on 2, or in other words, 13.5. So what we see is that when we have essentially the same terms, but the common ratio is a negative instead of a positive, as is the case of B, we see that the limiting sum is exactly half of the limiting sum when we're just purely using positive values. And I guess the way to think about that is that every half term we are subtracting. And so we're taking away from this 27. So essentially we have two halves and we're taking away half of them. So that means we're left with half the result. And that's a neat way to sort of think about this. Our next and last example says find the ratio of a GP whose first term is 10 and whose limiting sum is 40. So let's just break down the information that we have. We have the first term is 10, so A, we're going to say is 10. The limiting sum is 40, so S infinity I'm going to say is 40. And they want us to find the ratio of a GP. So what formula brings all these three terms together? And that is just the formula for a limiting sum, A on 1 minus R. Once we figure this out, we can just plug in our values. So S infinity we know is 40, A is equal to 10, and 1 minus R we don't know. To solve this, we can say it's equal to 10 over 40. So we'll say 1 minus R equals 10 over 40. 1 minus R equals 1 over 4. And doing some quick maths, we get that r is equal to 3 over 4. And so we can see that this is clearly a limiting sum because r falls within this range. And so this is essentially our question solved. So I hope this lesson made sense. And if you have any questions about anything that we've covered, please let me know in the comments. Be sure to leave a like and subscribe for more content coming soon. Thank you.